Yo, I was like 2 seconds from about to just say, nah, I don't feel like doing this, but I'm gonna start it up in a few seconds. Andrew, what's up, man? How you doing? Messing with this. All right, we're gonna save all that. Starting to get hot. There we go. All right, so we're gonna straight up get started. We got it. We got enough in the room. Let me share my screen. Where we going first? All right. So if you was here, this is week 2 of the EST3 rule architect training. This session is going to be titled Outputs and Wildcards. So if you know anything about EST rule labels, you got to have your rule label, input, your input side with your device type, you call that your device qualifier, your syntax, and also on your output side, the same thing. So if you want to write cleaner logic and avoid syntax error, this is the week that you got to lock in on, because we're going to get deep on the inputs, the outputs, the wildcards, the end variables, and I'm going to show you some examples. Then we're going to jump into the existing programming, and I added a few more smokes and some more devices so we can program them in. So let's go to the next one. So last week we went over a little bit of the input. We just breezed over the input, the output, a little bit of the wildcard, some labeling structure, and then we did a little bit of the project build. So inside with this week, we're just going to dive a little bit deeper into the rules, the labels, and actually understanding why we have to write these rules so that the fire alarm control panel can receive these inputs and actually have these output functions. So for this week session, we're going to go over again what are rules. This is going to be redundant because we got to understand what these things actually is doing in the background in this text editor. So when we download it into the fire alarm control panel, we know what's happening, so that we just become better programmers, become better thinkers, more logical. And once we understand how we could actually start seeing how this fire alarm system operate, it'd be way easier for us to start writing down these rules. You would just have to learn how, whatever company you work for, if it's Edwards, what are their syntax? That's what you got to understand. All right, so what are rules? Every rule reflects a live state in the system, whether that point is active, a supervisory, or an alarm point. When you write a rule, you're not just triggering based on a device, you're triggering based on the state of the input side. So if the input goes into alarm, the input goes into supervisory, the input goes into monitor, whatever state the input side of the rule goes into, the output functions you predefine will happen on the outside. And that actually happens from top to bottom. So whatever your priority rule is on the output side, you want to label that first. So have you ever written a rule that you just didn't understand why it wasn't compiling? A lot of times you get them them sleepy eyes, and you could just miss a comma, you could miss a semicolon, you could miss a single quote, you could have the wrong label, or you could be misspelling, you could be having a typo. So typos are also a very dangerous problem, especially when you're writing rules. So if you're not using Gen's editor, which is the software you can use to color code the rules or the text editor to let you know if you have any mistakes. So I got this rule right here, and I want you to take a look and examine this rule to see if you can pinpoint if this rule is actually correct. And I'll give you about 10 seconds. All right. So as we look here in this rule, when you write a rule, you have label, and your rule label, this rule right here obviously will not compile. It's missing a lot of the syntax that needs to be on this rule. So when you have your rule written, you have your rule label, which is smoke activation, and that needs to be closed within brackets on both sides. And then when you have down here on your input side, because we have the semicolon here, or rather the colon here, that's going to separate the input for the output side. So on the left side of the colon will be your input. So you'll have your device type, or your input device, or what the hell they call this. This would be alarm type. So meaning what your device, your smoke or pull, whatever it's going to be, what is the state of this particular device? So this label is level 1 smoke. So for the smoke detector, when this smoke detector goes into alarm, we want this smoke, whatever this label is that's for this smoke detector, we want this amp to turn on. But this rule right here is also incorrect, because we're not saying what type of device this is. We just have alarm, which is the qualifier, but we also need the device type. When we get into the rules, I'll actually show you that. So it should be alarm, smoke, and then your rule label, also with the colon, and then same problem over here. We turn it on the amp for this particular level. So a rule label is what's going to define the action of the input and the output side of the rules. So some of the advanced programmings, you could set up action events inside of the rules. So if you write in your rules with your rule labels, then you can control those physical individual rules with actions, and you can control. That's like an EST2 thing, but you can still do in an EST3. So you can control these events through actions. So that way you can, it's just less programming you have to write when you write in your rules. So on the input side, so we have the input event, we have the device type, and the device label. So those are three things you're going to need on the input side. So the input event will be alarm, the device type will be smoke, and the device label will be level 1 smoke. And there we go with our comma or colon right there for the input side. And if you look up here in the EST rule architect, if you want to be lazy, you could just put your scenario in here and it actually spit out the rules that you actually need. You would just have to change the labels to match it to your project. And on the output side, on the right side of the colon, we have the output event, the device type, and the device label. So it'll either be amp on, then you could turn a relay on, or non-supervised relay, then that level 1 fan, or you could just use the point type on relay. Just make sure you got these single quotes for your label, and then you have your semicolon. So I actually close out the that particular rule. Oh, let me go back. But if you have more than one rule that you want to write on the output side, more than one function. So if you have your fans, then you have your doors, then you'll have other output functions. You would use a comma, this guy right here. And then at the last output function, you will put your semicolon. So we're going to be using the n variable. So what is the n variable? The n variable can be used in a rule to conditionally select devices based on a numerical index used in their object label. When using the n variable, the numbers required to make the conditional true are specified on the input side. When the input statement becomes true, the number that is substituted for the variable on the output side also activates. So here's some ways you can use the n variable. We have the single number entry, and it has to be the same on both sides. So if you're using a single number entry, you will have to define that number on the output side. Same thing if you're using a range of numbers, and you can only go from up to about 32,000, from 1 to 32,000 or something like that. So if you're using the second one, which is a range of numbers, that'll be like in consecutive 1 through 10 or something like that, you will also still have to define that on the output side. And you could also define them in a combination of single numbers. So 1, 3, 5 through 7, 9 through 11. You could also define it that way as well. The n variable is also a mathematical operator that can be used in conjunction with the rules on the output statement to conditionally select devices based on a numerical index used in their object label. Excuse me. When using numerical mathematical operators, the numbers required to make the conditional true are specified by the n variable in the input side. So when the input statement becomes true, the number substituted for the variable on the output side in that n variable will also come true. There are some, if you're using the mathematical operators, that's with the plus and minus. So that's in a sense of using the same thing. If it's a small system, instead of using my n variable from 1 through 10, I could just say plus 1. So the rules will know if it's plus that n number, it will know to activate that second level or that third level or whatever level you're defining with using that qualifier. Wildcards. We have wildcards. Wildcards is that asterisk star that replaces any character, any word, any phrase. You need to be very careful with the asterisk cards because you could use this to activate anything and everything, and you could also make some mistakes, and you don't want to have some tricky things going on with your rules if you're not understanding how to use the asterisk cards. So some of the mistakes you want to avoid is typos in your rules, not paying attention to the proper syntax, single quotes, the semicolons, the commas, the regular colons, all these different things you need to pay attention to if you're not using the gens editor, so that way you can make sure your rules will compile. And you want to make sure you separate your input and output side using the colon, and learn how to make sure you properly close your rules using that semicolon. So let's get into what is this right over here? No, not this one. This is the drawings we're gonna actually, when we get into the programmer, I added the rest of these smokes, these modules. I also have this, you could download this and you would be able to download the SDU too. So you could actually finish some homework to do. You could put the first floor, we could do the mezzanine, and then the first floor, we can add those to the programmer. You can email it to me and we can go over and make sure these rules is correct. You make sure they compile. If you have any issues, you could actually send those questions in. But we're gonna do the complete seller. We're gonna add all of these devices, but I want to go over this other cheat sheet that I had compiled for the rules. So for our alarm activation, our alarm input type will be alarm or ALM. So this triggers when any alarm point goes active. We also have supervisory, which the point type is supervisory. That, of course, triggers when any supervisory, tamper, seal, or anything like that triggers a supervisory activation. Then we have the trouble detection, which could either be local trouble, first trouble. There's a bunch of different point types for the trouble detection that you can use inside the software. You have your central station messages. You have your plus will send the signal, and you have your negative send that will send the restore. So you have your activation and your restore. Switch activation, you could do switch or just SW. This is all for the input side if you're using for the switch. And then you have relay configuration. You would use relay configuration if, let's say, usually for like dampers, right? So when the relay goes active, it will send a confirmation so that way you can take that confirmation and then either do something else with it, turn something else on. But you would usually take that relay confirmation and then control either fans or some dampers after that. You have AC, so the system doesn't automatically send out this trouble signal. So when you're setting up the modcom, you will have to configure these messages so that way you can get your brownout, your ground faults, and all these other different trouble messages. And if you're using or if you're installing or writing rules for a voice system, you want to make sure you use the qualifier message on to turn on the evacs, not just on. So you will have to turn on the amplifiers. Once you turn on the amplifiers, then you have to turn on the messages so that way the messages could go through on the amplifiers. So there's a lot of programming you can do. But when it comes to that, it's actually fairly simple compared from simplex writing custom controls to Edwards is way simpler, because when it comes to the simplex programmer writing their custom controls, you got to do it, you got to write it out for each and every floor. So if you have a 20-story building, you're going to have to control each and every floor with 20 different rules. So you have to write a lot of rules when it comes to the simplex. But back to the Edwards. So the wild card, we have this, blow this up. So the wild card, we have this asterisk star. And once we get inside the programmer, you'll see what the object label is. And these are the object labels. And if you have, let's say, 10 smoke detectors, it'll be level 1, speaker 1. But this is just an example. This is a terrible example. But it'll be level 1, speaker 1, all the way to level 10, speaker 10. So that would be the label of that object. So all the smoke detectors will be level 1, speaker 1, or smoke 1. I'm going to use smoke 1 because this was used for the output side. But if we're using it for the smoke, this right here would be a smoke. So just imagine 10 of these. So the wild card will replace the 1, 2, 3, 4, pretty much that last character, because this character right here will be the numerical number 1 through 10. So that wild card could be used in any one of these sections of the label. The wild card could replace all the words that say LVL. It could replace all the words that have, if this is a number representing a number, if you use it here, it's going to replace all the words, letters, text, whatever that's in this field, SPK, and so forth and so on. Then you have your N variable. Making sure when you use the N variable is defined on both the input and the output side, rather if you're going to be using consecutive numbers, staggered numbers, or if you're going to just be using one number for the N variable. So here's a general alarm rule, and this is an alarm rule being used with the wildcard qualifiers. So this is anything, this is defined that if any alarm on this, it doesn't matter if it's a water flow, a pull station, a smoke detector, a duct detector, it doesn't matter. Whatever input activation that has the input type alarm, all of these things is going to happen. It's going to turn the amp on to the evac. So we're going to turn the evac tones on. This is a voice system. We're going to turn that level speaker on. Pretty much we're going to turn all of the speakers on for in this entire building. We're going to turn the messages on. So once we turn the amp on, once we turn the speakers on, now we turn the messages on so that way the message can go through the speakers. These are the pre-recorded message like alarm, go to the stairwell. This is just an emergency. This is not an emergency, or get out the building. Whatever the message is, you could pre-record that inside the audio. Then next we want to turn on the strobes, which is the visibles. And then here they're doing something with the AHU and the RTU. So they're probably shutting fans down, or they could be purging the system. So on the manual pull station side, they have a modcom. So they have contact ID that they're using in this particular system. So it's alarm level, any level pull station, any number pull station, because each object or each point type or each device need to have a unique label. So to change the label, just change the number. So we're going to send the account number plus send alarm. Once the point go active, you will put the account. This is the label for the modcom, or this particular account inside of the modcom. So whatever that account number, 123400001, whatever that account number, you would do that account number. Then a message, whatever the message is for that particular point type. Each point type have its own activation message and its own restoral message. So that's for the manual pull station. And for the smoke detectors, it's pretty much the same thing. Smoke, we're going to turn on these fans, and then we're going to send this message, smoke alarm. And then once the alarm clears, we're going to send this message for this account number as the clear. Excuse me. Same thing as the water flow. Water flow is pretty much activating. And one good thing about this, once you have all your rules, let's say one rule written, it's very easy to just really copy and paste, and then just change up the label text, change up the input side, and pretty much going to be activating the same output. So it makes the writing rules faster. You could just copy and paste a lot of these rules and then just change the labels on the input side. So on the AC failure, we have to write AC fail, and then the label is AC brownout star. When we go inside the object labels, you'll see why they're defining it as star. So we send in messages, the activation message and the restore message. Same thing here with the ground fault. So we defining all these things in a modcom, especially if you're using contact ID. And if you're using just zones, these are all just to be grouped up into particular zones, like a pull station zone, smoke zone, trouble zone, things like that. They also have an enable and disable switch. So you could either use S, or you can spell it out as switch. And they're defining it as the fifth switch. So switch number 5, they want to turn on this control relay for the hatch and blink that same LED, flash it fast. And here they're using a global disable switch. So if they're doing any testing, any welding, any construction, whatever, they hit this switch, the last switch, number 12, and number 12 is going to turn off everything. It's going to disable all of the output devices so that way they do not go into alarm. And another thing I don't see here is usually they will put a priority, this priority, so that way nothing else can override this unless you press the switch to turn everything back to normal. So I put aside some of the CMS event mapping contact ID because I always struggle when writing rules for modcom. So I needed a way for me to I needed an easy way for me to write modcom because I couldn't remember all of these codes. This thing was very confusing until I found a way to actually put it together. So these are the code formats for all the input device types: smokes, pulls, water flows, heat, tampers, COs, AC, ground, low battery, common trouble, and also trouble. Common trouble and first trouble is two different things. So when the system first go into alarm, when the system first go into trouble, that's the first trouble. Then if it stays in the trouble, that's going to be your common trouble. Pretty much like the first signal that goes into trouble will be your first trouble. All right, so now let's go into what we doing next, the programmer. So let's go over to objects. No, let's not go to objects. Let's go to cabinets. So modules, the SD card. So this is the loop controller card. And once I actually get my panel live on a board, on a wall I got over here, we'll actually start downloading and doing some testing on this fire alarm system. So I added some more smoke detectors and some ducts because last week we only added 1 smoke. So I added 4 more smokes, and then I added 2 more duct detectors. I added some more tamper switches and some supervisories for fire pump. So I'm gonna show you the drawings real quick. So right here we got three CT1s for the fire pump. So we got fire pump run, phase reversal, and power fail. We got the 1 smoke here and the 4 smokes here. So that'll be our 5 smokes. And I got to change one of the labels to elevator and then write a rule for that. And we have our 2 duct detectors. The pull station is this F. And then we have all of these tamper switches and horns and strobes. So that's all we're going to write the rules for. We're going to write a rule for the elevator lobby. And we don't have any water flows on this floor. So we don't have to write a rule for the water flow nor the tamper switches, but we can still configure it. So let's just go through the programmer real quick. To make sense of that switch, they would be using that 12 switch inside that rule that I just showed you, and they would be toggling that switch on and on to disable the outputs. Not for this one. There's nothing in here to disable. So what we want to do is I usually click inside the device type and then I just go SM so that way I can get to the smoke section. And we're going to make smoke number 5. We're going to make that the elevator lobby. Level 1 smoke elevator. So now let's say if I use the wildcard star, it will activate all of these input devices. All right, so let's put out labels. So first floor, I like to write all caps. We just put some generic information in there. So this would be this, let's call that the supply. And then we could just copy and paste this, Control C, save, Control V, and then call this return. All right, so we save that. We drop it down again. So let's scroll to the top. I'm just using the up and down arrows. We had tamper switches. Yep. So all of these are in the cellar. So we can say cellar, sprinkler room, tamper 1, all the way to however many tampers we had. Copy that. Let's go to the next one. Control V. It's not being in the fields for real too. Be trying to get out of there in 5 minutes, even though I got 1,000 points to program, but try to move as fast as you can. For this particular project, all of these tampers were in that same room, just like they had a bunch of tampers in this room. I lost my count. So we got all the tampers. What else we got? Oh, we do have a water flow. That's why we added that last week. I think we got added a pull station. Yep. So first floor, stair. So we got to write one for the pull. And I like to write down all of these inputs on another sheet of paper because I cannot be remembering all this stuff in my head. All right, so that's it. So if you have the reason that for the rules that I showed you here, right, that had the AC brownout with the asterisk star right here. So if you have more than one panel, if you have multiple panels, cabinets, you'll have more than one AC brownout. So you could just add that asterisk star and it will just ignore this last column so that way it could read these first 2 and then activate that rule or make that input statement go true. So that's all the objects. Let's look at the rules. So now we have smoke, water flow, and the door release. So now we know we added pull stations, right? So like I said, all we got to do is copy and paste. So pull stations release the doors, will activate the horns and the strobes. And if you want, you could have it shut the fans down, but we're not doing that. So we can copy the water flow, then we can paste it down here. Then we can change the rule label because the rule label always have to define what this rule is doing. So we have alarm flow, but we're going to change that to pull. And then what do we name this? Pull 1? I forgot already. See? Pull 1. So pull 1, we got this, we got what we got here, the colon. We're going to turn on the visible, the audibles, the visuals, and also the door release. Now, if that looks good, we'll click on, we'll close this out, and then we'll go to tools, rules, compile, and let's see. Yes, it compiles. So we got some warnings. We don't care about the warnings. Let's just keep it moving. And then we say yes to all. So even though I added all of these smoke detectors and I didn't have to write a rule for the smoke detector because we go back to the objects, these level 1, smoke 1. So the object label text is pretty much already defined. So when I come to the rules, edit rules. So level 1, I can't make this no bigger. So we have level 1, smoke 1. Actually, this would only set off 1 smoke detector, to tell you the truth. So I will have to put the wildcard star in order to make this go active. And we have the duct detectors, which we could also write a rule for that as well. So that rule will only activate this 1 smoke detector. It will not activate this smoke. So what I would generally have to do is, for this one here, I would probably put it elevator smoke, so I could write a separate rule. Because once I put the asterisk star here, and this is saying pretty much having the same information, this is going to be inside of that rule as well. I want this to be working separately just to activate the elevators. I don't want this to work as the rest of these smoke detectors. So if I just swap these labels, then I put the wildcard or edit rules. So we'll change that smoke to a wildcard star. Click on. So now that star will represent everything in this column, but it has to match level 1 underscore smoke underscore, and then that last column it just ignores, or rather it duplicates. So if it doesn't match, it's like this one here. Well, I just made another change, because we're going to have to change this, because I wanted to ignore this smoke detector here, and we write our own rule just to activate just the relay for the fan. But I didn't add a relay, not the fan, I didn't add a relay for the elevator recall. So next week we'll add the relay for the elevator recall, so we can write a rule for the elevator smoke detector, and also we could write a rule for the duct detectors as well. So inside this object label, I just want to go through these tabs real quick. So we have AND groups. So AND groups is a good place where you could use in, let's say, computer room. So you have smokes above the floor, you have smokes on the ceiling, you have smokes below the floor, and it's the raised floor that they have inside these computer rooms. So you would write or put devices inside of an AND group, so that way you would have this and that before an output activation. So I need a smoke and a pull station to be an alarm before this one activation. I need this smoke detector and 2 more smoke detectors to go into alarm before this output activation. And you define that through the activation number, how many of these things inside this list need to activate before the output event will take place. And all you would do here is just add a new group, and then just you go back to your objects, to select your devices, go back to the AND group, and then you just add your devices. So whatever devices that you would want into the AND group, you would have to go inside the object configuration side. Let me just get rid of this. Go on your object configuration side, and all you will have to do is just make sure you select whatever devices you want within that list. And once you do that, you bring it over here, and now you have that in that AND group. So whatever device that's within this AND group that need to perform whatever function, you identified here. So I need 2 activation, 3 of them to go into alarm before this AND group will go true. And once 3 of those smoke detectors, let's say under the raised floor, go into alarm, then that AND group will go and become true. Guard patrol. All of these menus here pretty much work the same. So you could have your groups that for your guard patrol, what are they going to be patrolling? What devices in a section of a building that needs some special attention or to be disabled, or whatever the case may be, this is the list, and you will put it on for the guard patrol. Same as instructional text, you could have information being sent to the to the display by particular devices that you add into a particular menu. Matrix is also like the AND group. So if you have a particular activation of a certain amount of devices within a certain matrix zone, I want to say 3 devices in this particular zone, or 2 devices in that zone, or 1 device in that zone. That's how you would pretty much configure the matrix. Partitions that work the same as a burglar alarm system. So you can separate your zones by, you will never use this right here. But this tab here, service groups, this is a big tab that a lot of people will always use. Let's say high-rise building, or let's say a school, you could put different wings in a service group, so that way you could disable the east wing, but the west wing can still stay active. This is pretty much the same as disabling the outputs. That's all you're really doing, but you putting it into service groups. So if I need to do work on the 3rd floor, I could disable just the 3rd floor, rather whatever devices I have in that loop, or whatever devices I have in that group, I could disable just that 3rd floor while the rest of the building stays active. And zone, this is how you would also group your devices into a zone if you were sending out zone 4-2 to central station. So you would put all your pull stations in one group. You will put all your smoke detectors into one group. You will put all your CO detectors into another group, water flows and tampers, and you would define these zones, and whatever those zones are, you hand those over to central station. So every time any one of those devices go off in that particular zone, that zone will become active. And you also will have to define that in the rules when it comes to that central station, that CMS central station message. So if you defining your rules for whatever the zone, let's say zone type pull, it wouldn't be contact, it wouldn't be these numbers for contact ID. For zone, it was only going to send 2 numbers, and it's a different way. You would just have to put the zone number. So if it's zone, whatever the zone is for pull, I don't know what it is, you would just put that in between these quotation marks for the activation and restore. All right, so for homework, I got these drawings inside of the training center, so you can download these drawings. I got the SDU on there as a zip file. Password for the SDU is 33, so you can cross-reference it. I just want you to add some more devices, write some more rules, and see if you can compile it. If you have any issues, let me know. Send it by Thursday. Send it back to me like an email by Thursday, so we can go over it next Friday and go from there. All right, so it's Friday, 7:44. I ain't eat yet, so it's just about that time that we got to get our food going on, and I want you guys to have a very good night. So let me go back to the other side so I could let me go back to the screen. There we go. Oh, there was more people. Too late. So you got a couple more joining. So we pretty much at the end, but I got some polls up. If you got some questions, send your questions. I'll hang out for like 15 minutes. If you have any issues downloading, need this training, these cheat sheets, the zip file, whatever, just let me know. I just seen you, Louis, Muhammad. I just seen you guys. Yeah, I'm letting y'all in now. So if you got any questions, shoot them. All right. Actually, hold on. Let me save this because I'm gonna export this. What's today? 2025. So let me export this. Let me do this. No, not that. Maybe how can I do this? I guess you should see some changes. I think I'm still sharing. That's probably what the problem is. I was sharing the screen, maybe. I don't know. I'm trying to upload. How do I? All right, I can't do that. How do I should be able to. Maybe I'll just put that as a link. All right, let me drop that. Bam. Actually, that's not what I wanted to do. All right, fellas, that's it for me. Peace out.